And get started on 6.1. We're going to go ahead and do number 24 first. Really simple when you're converting, let's see, what do we have? Radians to degrees, right? So find the degree measure of the angle given with the radian measure. Literally just multiply by 180 over pi, okay? I put these squiggly equal signs here because it's kind of like an approximation, right? There's a bunch of decimal points. So it equals just about 194.805 dot dot dot. Okay. So really simple. In order to change radians to degrees, just multiply by 180 over pi, and vice versa. If you have degrees and want to go to radians, just multiply by pi over 180. You just switch it. Okay. So for number 30, we're looking for coterminal angles. Coterminal angles are angles that are pretty much the exact same angle, right? Because we go around a circle 360 degrees, and so every time we add 360, we get back to that exact same angle, okay? So those are called coterminal. So all we have to do is add 360, and we get 495, and then we can add 360 again, right? 2 times 360. And we get up to 855. So these 495 and 855 are coterminal angles with 135. And same the other direction, right? So they asked 2 positive and 2 negative. So we're going to subtract 360 now, because we can do that. We're just going around a circle at 360 degrees. So all of these angles will be coterminal with 135. Okay. So just kind of finishing up there, subtracting 2 times 360. That's like going around the circle twice. So if you can kind of just picture that, it's like we have a circle, we have our angle, and then we go all the way around the circle 360 and get back to our angle. And then all the way around the circle again 360 and get back to our angle. And all of these angles are coterminal. Okay, cool. All right, let's go ahead and do, what are we on? Number 36, right? Okay, so we want to determine if these are coterminal, right? So we just basically need to see if these things are separated by 360 degrees, right? So we take 330 and subtract 360 from it, and we get negative 30. So these two angles are definitely coterminal because they're separated by 360 degrees. Make sense? Good. Okay, number 45. We're basically trying to find an angle between 0 and 360. So we have to add 360 to negative 800 a couple times in order to get in that positive 0 to 360 range. So we actually have to add 360 3 times. So that's why I do 3 times 360, right? But that 280 is a positive coterminal angle to negative 800. Cool. So number 48 here, let's see. Just trying to basically find an angle between 0 and 2 pi that's coterminal. So all we have to do, just like we were adding 360, same thing, 2 pi is equivalent to that 360, right? A circle is 2 pi around. So we can just add 2 pi, right? And all I did here in this step was just make sure that we have common denominators. So turned 2 pi into 6 pi over 3 so that I could add these two. And then I get pi over 3. And we're good to go. So coterminal, either degrees or radians. Degrees you're going to add or subtract 360. Radians, add or subtract 2 pi, because you're basically just going around a circle, right? Good deal. All right, so number, what are we on? 54 here. So the arc length, okay? So I kind of go through some, building this formula here. Show you all the pieces. So we have our radius r, and then we have some degree. That's called the central angle. Okay, we denote that as c, and then that arc length, they put it in this problem as s. So I just kind of go through and throughout this whole chapter use s as arc length. Okay, so the formula here for arc length is just 2 pi times the radius times the central angle c over 360. Okay, so in this problem here, we have our central angle that they give us, but it doesn't correlate to the S, or the arc length, the kind of side that they want, right? So what we have to do is figure out that, what's on the other side of that angle. Well, we can basically just subtract 360, 140 from 360, and that'll give us what that angle is, right? Because a whole circle is 360, so if that part is 140, then the other part has to be the remainder from 360, right? So we're just solving for this new C, or central angle, that corresponds to the arc length, the S, that they want, okay? So we just found that that is 220, okay? That little blue area is 220. So now we have the central angle that corresponds to the correct arc length that we're looking for, okay? All right. So had we used 140, we would have found this kind of pinkish area right in here, and that's not what we wanted, right? We didn't want that. We wanted the red. So that's why we had to change our C, our central angle, and figure out what that blue central angle is. Does that make sense? All right. All right, so now we're on 57. 57 is the area of a sector, okay? So, oh, I'm sorry, more arc length. I apologize. So we're doing more arc length. Next problem is going to be area of a sector. So arc length and radians, right? It's not too different. We have our S, and that just actually equals whatever that central angle is given in radians times r, whatever our radius is, okay? So in this case, the radians that they gave us was 3, so we just multiply that times 5, our radius, and we get 15, and there you go. You have that arc length that they were asking for. Okay, and I'm just making a note here that C is the central angle. Doesn't really matter if it matters obviously if the central angle is in degrees or radians, because that tells us what formula to use. So now you have the arc length formula for radians and degrees. Okay, so now we're doing the area of a sector. Okay, number 63. All right, so the area of a sector, it's not too bad. We have two different types, right? We have for radians and then we have for degrees. So for radians, we have C, that central angle, over 2 times r, the radius squared. Okay, for degrees, we're going to go ahead and we'll have, let's see, C, that central angle, over 360, and then that is times pi r squared. Okay, so on A and B, they give us two different types, right? We have a degrees and then a radians. So we just are using the two different formulas for sector area, and we're just plugging in that central angle, that C, and then the radius r, and it's pretty straightforward from there. You just kind of run through that. All right. And then B, remember that is the radians, right? It says there's 0.5 radians, so we have to make sure to use the radians formula. So we have 0.5 over 2 times that radius, which is 10 squared, right? So we calculate that and we get 25. Alrighty, good deal.